Up in 5.3, if you recall from, half a week ago, last Friday, we were talking about the square root graph in this one, okay? This square root graph, we had to reflect, stretch, move it left and up. My suggestion here was that we do the reflect and stretch by multiplying by -2. We graph those points, and mine it's on red, and then I move them left 3 and up 5 to get my final graph, okay? Now, the other thing that we ran out of time to talk about was domain and range. And I don't really have a lot of space, but I'll make it fit. Thoughts on domain? How far left does this graph go? How far right does this graph go? So how far left does this graph go? Okay. That point right there is 3 left of the origin, isn't it? So it's going to go 3 to the left, so it goes to -3. And then how far right does it go? It's going to infinitely right. So our domain, I'm going to list as -3 to infinity. Infinity always uses a parenthesis. What about the -3? Parenthesis or bracket? It's a bracket because that is a point on the graph, right? We're touching the -3. So -3 to infinity there. And let's talk about range. Think carefully here. On range, it's how low to how high. So how low is this graph going? -infinity. Yes, as it's going off to the right, it's getting lower and lower and lower, isn't it? So my range is going to start at -infinity. And then how high does it go? What's that highest y value it touches? And right there, it's at a y value of 5, so -infinity to 5. -infinity, of course, has a parenthesis. 5 has a bracket. Okay? Questions on the domain and range there? Okay. So let's talk D then. D is k of x equals 2 times the cube root of x minus 1 minus 3. Okay, talk to me about the pieces. What are the different functions you see happening here? What are the 2, 1, and 3 telling me to do? What are we saying there? Because I think I'm hearing you guys wrong. Reflect. But in order to reflect, the 2 would have to be negative. And I don't have a negative on the 2. What does the 2 tell me to do? Okay, it's a number multiplying out front, and it is a vertical stretch because it's bigger than 1. Okay, so we are going to have a stretch by a factor of 2. What else? Did I hear right? Okay. The -1, it's under the radical. It's with the x, so left to right opposite the sign. So right 1. And the -3 tells me what? Down 3. Okay. And what graph are we doing this to? Which graph is this? This is the cube root of x graph, isn't it? Okay, so you got to pay attention to which graph you're starting with. Okay, with this in mind, okay, you could go ahead and do the right one first, but here's the deal. The stretch has to happen before you move it up or down, okay, because we have to do the pieces on the x. Easier, in my opinion, is that we do the stretch first, then we'll do the right one down 3. Now, you don't have to make the XY chart, but that's my suggestion as we get started on this. So pull from the front of your notes, what were my values for a cube root graph? A cube root graph was what? Started with -8, so -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2, yes? Okay, be familiar with those values. Those are all perfect cubes. Now, my suggestion is, okay, what do we need to do? We need to vertically stretch it by a factor of 2, which means we need to multiply what by 2? We're multiplying the y values by 2. Okay? And so we're going to multiply just the y values all by 2. Now, you can do that in your head. You don't have to necessarily write it down. But for the benefits of going through this as a class, I'm going to write it down. So I'm going to write down what my y values are now that I'm multiplying by 2. Negative 2 times 2 is negative 4, negative 1 times 2, negative 2, 0 times 2, 1 times 2, and 2 times 2. Okay? So, if you recall what we did on Friday here, we didn't change the x values. They don't change with a vertical stretch or compression. We're going to take our original x values, our new y values. Okay? My suggestion would be that you graph those. And then after you graph those, what do we still have to do? Then you're going to move them. Okay? So after we graph those original points, we will then take them and move them. Where are we going? Right 1, down 3. Okay? If you find another combination that works better for you, that's fine. So let's see. I'm going to do my original points in red. So with my stretch, instead of left 8 down 2, I'm left 8 down 4. Instead of left 1 down 1, I'm left 1 down 2. 0, 0 stays 0, 0. You can't stretch a 0. Instead of right 1 up 1, I'm right 1 up 2. Instead of right 8 up 2, I'm right 8 up 4. All that vertical stretch did is it doubled how far it is from the x-axis. If it was below, it stayed below and just went double the distance. Same thing for above. Now, I'm not going to connect those dots because what am I going to do with each of those dots? Move them. Right 1, down 3. So I'm just going to count each one. Right 1, down 3. And right 1, down 3. Keep your dots separate somehow or another, right? For me, those new blue dots are the dots I'm connecting. And before we move on, we got to talk domain and range. So think about domain and range here. Domain, what are we thinking? Okay. All real numbers, negative infinity and positive infinity. It's going infinitely left and infinitely right. Range, what are we thinking? Is it all real numbers again? Is it going infinitely down and infinitely up? So again, negative infinity to positive infinity. Okay. So a little bit of review of what we did on graphing. Look back to your front side for review of graphing when you get to homework 2. Okay. Okay. Next section. Rewriting the radical functions so that we can identify the transformations that are happening. Okay. I can't mess up here. Jeez. As we look at them right now, the transformations, how far we're moving left or right, up or down, the stretches, those type of things aren't as obvious as they could be. Okay? So what I want you to do is look for things that we can rewrite here. So A, what do you notice under that radical? Okay. 4x and 16 both have a GCF of 4, yes? So, okay, I'm going to take a step here. think under that radical. If I factor that 4 out, I'm still under the radical. If I factor that 4 out and put 4, and then in parentheses, I would still have x plus 4, correct? Plus 7 is still just hanging out there. It has nothing to do with that. We have a factor of 4 under the radical now. What do you know about a 4?
It's perfect square.
It's a perfect square, yes? What's the square root of 4? 2. Where can I move that to then? If it's, we can move that outside. So I can rewrite this. The square root of 4 is going to go out front as a 2. What's still under the radical? X plus 4, and then there's still a plus 7 at the end. And I'm going to put my h of x out front. So this function right here can be rewritten as h of x equals 2 times the square root of x plus 4, and then plus 7. Does this look what a function looks like when we start identifying our transformations? Can you see about 3 transformations happening here? You can. We could see part of that in the original, but when you have that 4x plus 16, this is not a moving 16 because I have 4 multiplying by the x, okay? By now having it x plus 4 under the radical, we have our transformations easier to identify. So when you're asked to rewrite the function to make it easy to graph using transformations, that's the idea we're looking for. Describe the graph. So in words, what is this graph doing? In other words, list all the transformations, basically. So what are we going to see here? We're going to see a vertical stretch by a factor of 2. What else? What? I heard something. Couldn't hear what it was, though. We're going to go 4 which way? Left. And we're going to go up 7. Now, one last question. What graph is this being done to? The square root graph, right? So if I look at my notes, I have it written as the graph of y equals square root of x is vertically stretched by a factor of 2 and translated left 4 units and up 7 units. Okay? So just because we're dealing with different possible graphs, what are we doing? You know, what's our specific graph? Okay? Put it in words how you want. But something along those lines. The graph of y equals square root of x is vertically stretched by a factor of 2. And if we use that fancy good vocabulary word, we can say translated, although it's also moved. Translated left 4 and up 7 units. What time did I see your email says?
It's either, he said it's either 10:20 or 10:25.
10:20 is what my email says. Okay. So.
Actually,
I have one email. It has one student name in
it
it.
didn't say Patrick.
No, it does not. It has the one name of the person that normally leaves right after my class to get to Career Center.
That's weird.
So,
You must have messed it up.
we're going to finish these notes. Savas is out there. Make sure you get Savas done and be working on the review worksheet.
Paul Patrick, yeah.
Yeah, I think Paul Patrick.
He's a Patrick.
Drive careful. Okay, B. G of x. G of x equals negative square root of 9x. What do you see? We see a square root?
Yeah.
Can we do something with the square root of 9? If you think about this as just 2 separate pieces, right? It's square root of 9 times square root of x. What is the square root of 9? 3, and where's that go? Outside. So what am I going to rewrite this as? Negative 3 times the square root of x. Okay, that one, maybe I should have started with that one. That one was a little more obvious, wasn't it? Okay. So, let's put it in words. What are my pieces?
Square root.
Talking about a square root graph, y equals square root of x. So the graph of y equals square root of x is what?
Reflective.
There's a negative out front. So negative is going to reflect it across which axis? X-axis. And the 3 says vertically stretched by a factor of 3. In terms of the vertical stretch and the reflection, it's not going to matter which order you mention those in. Okay, it's not going to matter which order you would do those in. So, the graph of y equals square root of x is reflected across the x-axis and vertically stretched by a factor of 3. Okay. C. What do you see?
Divide. Reduce.
Okay. What do we know about 27 and 81? They're perfect cubes. Okay. Think in terms of GCF. Okay, we can divide those both by what? Okay, 27 and 81 both divide by 27. Since that first term is negative, I would factor out a negative 27 under the radical. So I'm going to have the cube root of negative 27. When I factor that negative 27, it's going to be x. Positive 81 divided by negative 27 is going to be minus 3. Does this work for us? What do we know about negative 27? It's a perfect cube. And we want a perfect cube this time, don't we? We're in cube root world. There's a little 3 telling us we're in cube root world. The cube root of negative 27. Negative 3. So we're going to have a negative 3 times the cube root of x minus 3. And that would be our way to rewrite f of x. Okay? Do remember, you can take the cube root of negatives. Yes, you just get negative answers. And we need the pieces. What all do we need to state here? Okay. There's a reflection because there's negative out front. Vertical stretch because it's 3. And minus 3 tells me it's under the radical, so left to right opposite sign. So right 3. And don't forget to mention what kind of graph are we starting with. Our base graph is a cube root. So the graph of y equals the cube root of x is reflected across x-axis, vertically stretched by a factor of 3 and translated right 3. That's a lot of 3's in that problem. Okay. Start looking at the next section. Hello. Oh, okay. I will have to change your attendance later. Okay. Okay, thanks. Bye. Okay, guys. Last section. We're going opposite of what we were doing earlier. Okay? Earlier, we had an equation, graph it. Now, we have a graph, write an equation.
That's equation.
That's what?
That's equation. We had an equation, we were graphing it. Now we got a graph.
So we're going to equation it. Okay? So, what radical function is represented in each graph? So basically, we're going to write that equation for each problem. Okay? Let's start with details. Okay? What are key pieces of information we need to know to write an equation for example A as we look at this graph?
Is that square root graph?
Okay. Probably helps to recognize what kind of graph this is. Can we agree that this is a square root graph? Half of a sideways parabola. Where's the square root graph going? And if you look, where does that vertex normally start at?
0, 0,
Normally starts at 0, 0. Where is it starting?
7, 1.
1, 1. So that graph is going to move where? Right 1 and up 1. The only other thing to check, is it a normal shaped graph? If I count over from my original point, the first point is over 1 up 1. The next point is over 1, 2, 3, 4 up 2. That goes with our original XY chart, right? So no stretch or compression to worry about. Okay, here's what I'm going to write for you. Y equals, or you can put f of x equals if you want. I have y equals on my page. Doesn't matter. Y equals what?
Square root. X. Minus 1.
Okay. Right 1. You put a minus 1 under the radical.
Plus 1.
Up 1. We put a plus 1 outside of the radical. Okay. If I took Desmos or a graphing calculator and I plugged that equation in, would I get the same graph I'm looking at?
I hope so.
You should, right? You should. That's the key. That's your goal. Okay. Keep moving. What are you thinking about B?
It's cube.
Okay, it's a cube root this time. Where's that cube root graph going?
Right.
Normally my centering point starts at 0, 0. Where is that centering point now? I guess the question becomes, which is my centering point? They're kind of confusing us. They only gave us 1 or 2 points. If negative 1, 4 is my centering point, I need to be able to go right 1, up 1, and left 1, down 1. I can go left 1, down 1, but I can't go right 1, up 1. If negative 2, 3 is my centering point, can I go right 1, up 1, and left 1, down 1? In other words, where else could I put a point in to make this visual work for you? So what's that mean my center point is? It's at negative 2, 3. Okay, so it was at 0, 0. Now it's at negative 2, 3. So this graph moved where? Moved left 2 and up 3. Any stretch or compression or reflection to worry about? It's definitely not reflected. It goes the normal direction. If those first set of dots are right one, up one, and left one, down one, that matches with our 1, 1, our negative 1, negative 1. So that means there would not be any stretch or compression. It would just be the normal graph. So, y equals what? Cube root of x, left 2 is shown by plus 2, and up 3 is plus 3. Okay. Let's move quickly, I guess. What type of graph is C? It's a square root graph. I should have a point at 0, 0. Where is that point at instead? It went where? Left 5 and down 4. No reflection. It looks normal, yes. What about a stretch or compression? Looks like there is one, doesn't there? Okay. Although I don't know. What? If this is a normal graph, it needs to do what? It needs to go over 1, up 1, and then over 4, up 2. This point it has listed here. What is that? Negative 5 to negative 1 is over 4. 4, negative 4, negative 2 is actually up 2. Are you guys realizing what they did to us here?
No, not really.
Okay, fair enough. What is my x-axis counting by? 2, 4, 6, 8, 10. What's my y-axis counting by? Negative 1, negative 2, negative 3, negative 4. Did they actually stretch it?
No.
They did not. And that's because if I count this point over to this point, it is over 4, up 2. Over 4, up 2 is a normal point on the graph. Over 1, up 1 would be going over here to negative 4 and up 1 to negative 3. So there's not actually a stretch. They tricked us, okay? So we just have y equals square root of x plus 5 for left 5 and minus 4 for down 4. Okay, let's talk D real quick. Yes, it is. D, what kind of graph is it? It's a cube root. Okay. How far left and right and up and down did it move?
None.
It didn't, because it's still centered at 0. What did it do? My first set of points, instead of being over 1, up 1, and over 1, down 1, are over 1's 2. What's that mean we did? We vertically stretched by a factor of 2. Because my 1, the value that should have been 1, doubled to be 2. So that is a vertical stretch by a factor of 2. Anything else happening? No. Write your equation. Y equals, how do I do a vertical stretch?
2 cube root of x.
2 times the cube root of x. Okay. And one more, I'm going to try. It is a square root, yes. Should be starting at 0, 0. Instead, it starts at 1, 0, so it went where? Right 1. Did it stretch a little bit? Yes. Over 1, up 2. So again, it is a vertical stretch by a factor of 2. So y equals 2 times the square root of x minus 1. Okay? So, 5-3 in Savas. Give it a try. You need to work on it between today and tomorrow. Come back tomorrow with questions, okay? Huh?
You wrote Math Excel.
Where did I write Math
Right there.
Excel?
Right there.
Oh, wow. I did, didn't I? Okay, Savas.
So now I don't know where my homework's at. Oh no, I didn't do my homework.
I think you'll figure it out.
Where's my homework?
Okay. Homework will be in Savas. Wow. I went back a year. Make sure you have those review worksheets with you, too. Oof, rough.
Rough morning.